Well, in today's class, we are going to learn about construction principles. So, here, if you see the construction activity encompasses a set of coding and testing tasks. Okay, this construction principles includes the tasks of a coding and testing. These two tasks will come under a construction phase. Okay, that leads to operational softwares that is ready for delivery to the customer or end user. So after finishing of coding, we are sending that overall project to testing unit. So after finishing of the testing, then if it is satisfies the overall business goals of that particular project, then we are going to deliver that project to a customer, isn't it? Okay, so this is the coding and testing tasks. Here the construction phase have first of all coding principles and concepts, and also testing principles and concepts. Okay, this construction phase has again coding principles, testing principles. These coding principles are closely aligned programming styles, programming languages, and programming methods. So now we are discussing about coding. Coding in the sense it is purely about programming languages. Which kind of language we are going to use to develop such a project? Okay. So what are the principles we need? What are the software configurations we need? What are the hardware configurations we need to develop such kind of projects? Like that, everything it is related to a programming language and support tools or supporting environment to that programming language, right? After that, we are going to learn about testing principles. This testing principle lead to a design test that systematically uncover different classes of errors and to do so with a minimum amount of time and efforts. So each and everything whatever we have made related to a project, that should be tested first. It is a small what a small function or big function or overall function. Okay, it's a small part of a project, big part of a project, or that is a overall project. We should perform some kind of testings on that particular project. Then only we will get the idea whether this is working okay properly or not. For example, if we write one program, okay, by using C or C++, anything. So after writing overall program, first we will check it out. By giving the inputs to that program, we will check whether it is giving correct output or not. After checking one time, we may check two times or three times or four times itself. Okay, why? Because if it is working for only some kind of values or any kind of values, it is giving proper exact output or not. Okay, if I'm entering negative value, suppose if I have written one program addition of two numbers. Okay, suppose if now I have written one program for addition of two numbers. If I'll give the two numbers 20, 30 as input, it will give as usual 50 as output. That is worked normally. If suppose I have given okay minus 50 okay plus 20, what it will do? Whether it will give exact answer to that particular negative value. Here I have produced a negative value. So all we know that it will accept the negative values also. So minus 50 plus 20 means it will give some minus result in such a case. Okay, instead of that, I'm going to check for a third experiment is I have given what some character kind of data. Instead of giving the numbers, I have given some characters or special symbols. It will calculate the addition? No, it won't. Okay, so I'm testing that. Suppose if I will give the number, now I asked for, I have written the program for addition of two numbers. No, so first my first number having, okay, it's almost 20 numbers. Plus second number is also having 20 numbers, which means, for example, you may take first, my first number is 200 and 200 crores, 57 lakhs, 96,000, some 521. This is my number one, and like that, number two I have given. If I'll ask for addition of the two numbers, our program will support or not? 100% it won't support such kind of values, isn't it? It has some limitation, it has some memory power. Okay, while assigning or declaring variable declaration, we are giving how many number it will take. If it is integer type of data or character type of data or a float type of data, we are okay assigning starting itself. Then only we are going to use. Okay, so based on that that particular size of the data types, it will allow only that numbers, that length numbers only. Okay, apart from that, it won't take any other numbers. It won't work for such kind of values. So like that, if we have developed one function, one thing for one purpose, so we have to check that one by applying multiple examples on that, then it will give correct results for all. Then that is good one, that is one kind of testing. Okay, without testing, how we will give? Okay, it will bear, or it will I mean it will support all kind of positive values, or it will support positive values always, as well as negative values. Okay, or it will support some character data or not, like that we should apply each and everything we are going to test. Okay, already before going to release a medicine in a real world, they should apply that particular medicine on human, on some what animals, whether it is working properly on animals or not. Okay, they'll test. If it is success, then they'll try on human beings, isn't it? So testing also play an important role in software engineering. Before going to deliver a project to a customer, we should test that particular, okay, developed project one time, two times, three times, like that. Why? Because to give the quality output to a customer, right? So in construction phase, we are going to learn, construction principle. Here we are dividing this construction principle into coding principle, testing principle. Let us see one by one again. So before going to coding and testing principle, first of all, there are some preparation principles are there. We will study these, then we are going for coding principles, then testing principles, right? So if we'll see the preparation principle, what are the preparation principles here? Before going to write online, before going to write one line of code to your project, before going to write one line of code your project, you should check whether that will be satisfy the below points or not. You should check for a below points. What is the first one? Understand the problem you are trying to solve. So which kind of problem you are going to solve? First, you should understand that problem thoroughly. Second one, understand the basic design principle and concept. What we need to understand here? Concept, and what is the basic design principle of that particular project. Next, pick a programming language that meets the need of some software, which means first of all here we need to pick up one programming language. Suppose which is suitable to your project. So based on the project requirements, whether which language is support this kind of what features of a customer, based on that nature of the software product and as well as a okay features of a, that particular project, you should choose one programming language like Java, C, C++, Python, any one of the languages. Okay, even Jira also there. Okay, so first of all, choose based on the product requirement, whichever asked by a customer. After that, select a programming environment. So here the programming environment is also needful for one, which means you may execute, suppose I have chosen one language that is C programming. Okay, to develop one project, I have chosen a C language. Okay, to develop that particular project. So C language will be executed in by using Turbo C. You can execute the C programs by using Turbo C or Turbo C++, or by using Pretty also you can execute your C language programs. So there are three sources, there are three multiple environment, three kinds of environments are available to execute the C language programs. So which one you are going to choose? Which one is best for your project? Like that, you should select programming environment too. Okay. Next, create set of unit tests. So after developing each and every small tasks, you should apply some unit test on that particular program, which means first of all we should prepare some unit tests, which means suppose now I'm going to write a addition program. So that program, if I'll give this kind of inputs to that program, it will produce this kind of output. If I'll give this kinds of input to that program, it will give this kind of output. Like that, first of all we should get ready a input and output. Like that, not only one or two, more number of three or four examples you should prepare. After writing a coding, after finishing a coding of that particular function, you should apply whatever you have prepared three examples. Now you should apply that examples to your program. First you give the input. Okay, it will give the output now. So that output is matched to your general calculation or not. If it is matched, okay, success. I mean, one testing is over. Next, for applying of second results, third results, fourth results. So like that, previously we have discussed now what is, first of all, apply 20 plus 20, sorry, 20 plus 30. So it will give as usual whatever we think the output of that 20 plus 30, as usual 50, it will give 50. Okay, that system, that program also given 50 means okay, this will be worked correctly. And also apply, okay, minus 20 and plus 30. Then check whether it will be, so minus 20 plus 30 means what is our answer, expected answer there? Plus 10, isn't it? So apply that two values into the program. So it will work according to our expected output. So okay, test 2 is over. So like that, first of all you should get ready a unit test functions before going to develop a function or before going to develop a code. Sometimes you should prepare test cases. Okay, after developing the test cases only you should get ready a coding. Then if the coding part is developed, apply the test cases whatever you have designed earlier to this particular program. Okay, 1 2 3 4. If it is passed the test means you will put okay 1 2 3 4. So we have applied all test cases on this particular program. Okay, we have checked properly, it is executed. Okay, it has given correct output, right? So like that, you should create some unit test cases before going to develop a coding. Then after creation of some test unit tests, okay, unit test testing is also some coding. Okay, so after creating some tests, then you are going to write a coding part. Okay, this is the preparation principles in construction phase. If you'll see the next slide, it is a coding principles. What it is? It is about coding principles. What are the coding principles we have here? First one is, okay, constraints your algorithm by following structure of programming. Okay, whatever construct your algorithm, first of all you should construct some algorithm based on your okay task. In first year you have learned in FC. So before going to write a program, first of all you should construct one algorithm to that particular problem statement or some or some problem. Then only after that you should write a program, which means algorithm is a universal one. If you write one algorithm for a problem statement, that algorithm may be okay implemented by using C, CPP, Java, okay, .NET, Python, okay, any kind of language we may execute. Okay, an algorithm is the universal solution. So by taking that algorithm by steps, you can implement that steps in any kind of programming language. So that's why first of all you should construct one algorithm for your problem statement. Okay, after construction of algorithm, then you should apply the same steps whatever you have implemented. Accordingly, you should implement your coding by the language whichever you have chosen to implement. Okay. Next, consider the use of pair programming. If there is a need of pair programming, you should implement this mechanism. What is the pair programming here? Pair programming in the sense, ask the people to work on something togetherly. Okay, if more than one person is going to think about a single module, or they are togetherly work on particular writing of particular program, that is called a pair programming. If I asked you to write a okay program for palindrome, okay, write a program to implement the palindrome. If suppose one person will be implemented, one person should write the coding means, okay, the coding is correct, that output also will get proper output, there is no errors, nothing, exact result we will get. But the same program will be implemented by okay 2 or 3 people, means they'll share their knowledge, okay, they'll apply their own talents onto that particular program, and they will try to decrease the coding, they'll try to decrease the number of lines of a program. Okay, and also they are trying to save a, I mean, they're trying to execute that particular program as fast as possible, right? Okay, how we are going to decide which program is best program? If 10 members are written the programs for a single concept, if I asked you to write a program for factorial number, okay, so 10 members are writing the program individually, each and every member written a program for a to find a factorial number, isn't it? But if among your 10 of student, which student is a best student, but all programs are correct, all students programs are executing and giving exact factorial numbers, proper output to my program, isn't it? But I won't say 10 members are perfect ones. Okay, 10 members are 10 programs are perfect programs. So among the 10 members, which person written that program? Which person decreased the number of lines of code? Okay, as well as which program will be executed in fast. So based on that, okay, I'll say that the best program. Okay, so if you want to create such kind of solutions to a given problems, then there is a need of working of people together on a single function, right? That is called a pair programming concept, which means this is the just more than one person can work on a single task, or all togetherly trying to develop a single program or task, isn't it? That is called a pair programming here. Next, select data structure that will meet the needs of the design. So based on our design, so which data structures we are need. So this is because I have discussed, I have asked you whether you know this about the subject or not. Okay, which kind of data structure is suitable to you? Data structures in the sense, many are there, na? Stacks, queues, heap data structures, hashing data structures. So different data structures you have. So which one is suitable to your design? Based on that, you should select your data structure. In software definition also, you will get this data structure word, okay, to implement the problems. Right. Coming to the next one, fourth one, understand the software architecture and create interfaces that are consistent within it. So, first of all, you should understand the software architecture and create interfaces. So, we have discussed about this word also, interface, user interface, isn't it? So, this software architecture means it's a overall project architecture outline. So within that, we should create first some user interfaces that is easy to use by a end user, isn't it? So we should understand the overall the architecture of that project and also some how to create user interfaces. Okay, whether that user interfaces has all the features or not, or it will be has the data consistent data we have on that user interface or not. Okay, like that we should understand. Next, keep conditional logic as simple as possible. If any kind of conditional logics are, if condition or something for loops, okay, conditional logics are there now. So while implementing these conditional logics as simple as possible, and also create nested loops in a way that makes themselves is testable. So nested loops can be nested loops in sense loop within a loop. If there is a need of suppose if you want to implement a multiplication table, you need to write a loop within a loop, isn't it? So such kind of loops, if nested loops, nested conditions are there means, okay, try to recall, iterative functions, you should apply iterative functions on that loops. Next, select meaningful variable names. Already we have discussed this word in C language variable names. So while choosing variables, Better to take those names related to your what a problem statement, isn't it? Now we are going to calculate a okay summation. In the sense you need to choose value 1 or value 2, and uh, sum equal to value 1 and value 2. Here we have declared three variables: sum, value 1, value 2. Suppose subtraction operation we are going to perform means subtract sub value 1 value 2. Okay, why? Because why we are choosing that word sum like that? Because now we are going to write this program to implement that such kind of operation, so it will impose that operation, no? So that's why you should choose your variable names related to your task. Okay, and write code that is self documenting. So write code, what is the code we have written, that should be saved itself. Next, create visual layout that aids understanding. Okay, so if there are any okay necessary to create some blank lines, blank spaces in user interfaces, you should create such kind of things also by using a programming languages. So this is about coding principles. Okay, in tomorrow's class we are going to learn testing principles, as well as deployment principles and some validation principles too. Okay.